Question 1. Solve each of the following quadratic inequalities by using graph sketching method, number line method, or table method. So for A and B, I'm going to solve it using the graph sketching method, CD using the number line method, and EF using the table method. So first look at the graph sketching method. So I have two examples here. So for the number 1, let's say this is the graph that you get, and Qx is the quadratic functions. So if your quadratic functions is greater than 0 or greater than or equal to 0, then the range of the value of x will be determined on the graph above the x axis. So it will be here. Therefore, for the quadratic equation is greater than 0, the value of x will x less than a or x greater than b. And if your quadratic equation is greater than or equal to 0, then the x will be less than or equal to a, or x is greater than or equal to b. And for question number 2, this is the graph that you get. AB is the root of the equations. And if your quadratic equation is less than 0 or less than or equal to 0, then the range of value of x on the graph will be determined below the x-axis. So the range of the value of x will in between a and b. So when your quadratic equation is less than 0, then the value of x will greater than a but less than b. And when your quadratic equation is less than or equal to 0, then the value of x will be greater than or equal to a but less than or equal to b. So now let us look at questions A. X squared less than 4. Next, x squared minus 4 less than 0. So number 4 is a perfect square, so I can write it as 2 square. Now I'm going to factorize this. So we have learned this before. When you have a squared minus b squared, when you factorize it, it will be a plus b. Another one is a minus b. Therefore, when I factorize this, it will be x plus 2, x minus 2 less than 0. Now, to find the roots of this quadratic equation, I'm going to let this x plus 2 and x minus 2 equal to 0. Therefore, the x is equal to negative 2 or x is equal to 2. So now I'm going to plot this graph. This is the graph that you're going to get. So the A here is positive, therefore you're going to have a U shape, and you don't have the B. Therefore the y-axis is going to be the axis of symmetry. And you have the roots here, which is negative 2 and 2. And you're going to have the C, which is the y-intercept, negative 4. As this quadratic equation is less than 0, therefore the range of value of x is on the graph is determined below the x-axis, so which is here. So the solutions for questions A, the x is greater than negative 2 but less than 2. Question B, 2 minus x, f minus x less than 0. So first I'm going to expand this so that I will know what is the value of A, B, and C. So after expansion, I'm going to get 16 minus 2x minus 8x plus x squared less than 0. Next, I'm going to rearrange this. So x squared, and for this like term, after you solve it, you're going to have negative 10x plus 16 less than 0. Therefore, I know the A is greater than 0. Therefore, I'm going to have a graph of a U shape. and the y-intercept is equal to 16. And when you factorize this, you're going to get x minus 2, x minus 8 less than 0. Now, to find the root of these quadratic inequalities, I'm going to let the quadratic inequalities equal to 0. So when x minus 2, x minus 8 equal to 0, the x is equal to 2 or x is equal to 8. So when I plot the graph, it's going to look like this. So here is the y-intercept, which is equal to 16, and the roots will be 2 and 8. As this quadratic equation is less than 0, therefore the range of value of x is determined on the graph below the x-axis. So it will be here. So the value of x will be in between number 2 and 8. So the solutions for questions B, the x will be greater than 2 and less than 8. Question C and D, we're going to solve this using the number lines method. So first, look at the number lines that I have here. The A and B here is the roots of the quadratic inequalities. So this yellow region is for the part x greater than b. This blue region is for x greater than a and less than b. And the green region is for x less than a. If you do a test point for each of these regions, by inserting the value of x of each region into the quadratic inequalities, the yellow parts, the quadratic inequalities, will always greater than 0, which is positive. This blue part, the quadratic inequalities, will less than 0, which is negative. And for this green part, the quadratic inequalities will always greater than 0, which is positive. So for a quadratic equation which is greater than 0 or equal to 0, the solution is always on the positive part on the number lines. So for quadratic equations greater than 0, the solution will be x greater than b or x less than a. And for quadratic equation greater than or equal to 0, the solution is x greater than or equal to b or x less than or equal to a. And for quadratic equation which is less than 0, the solution will be on the negative parts on the number lines. So for quadratic equation less than 0, the solution is x greater than a and less than b. And for quadratic equation less than or equal to 0, the solution is x greater than or equal to a less than or equal to b. So now let us look at question C. So first I'm going to move 4x plus 12 to the left. So x squared minus 4x minus 12 less than or equal to 0. Next, I'm going to do the factorizations for this part. X minus 6, x plus 2 less than or equal to 0. So to find the roots, so I'm going to let this quadratic inequalities equal to 0. So when x minus 6, x plus 2 equal to 0, the x is equal to 6 or x is equal to negative 2. So now this is the number line that I have. The negative 2 will be on the left and the 6 will be on the right. So for this region, this is x greater than 6. The middle part here is x greater than or equal to negative 2 but less than or equal to 6. So this one will be equal here. And for this part will be x less than or equal to negative 2. As these quadratic equations is less than or equal to 0, therefore the solution will be on the negative parts on our number lines, which is here. Now, To confirm it, you can do a test point for this negative regions. So for example, now for this region, the x is in between -2 and 6. The easiest one is I'm going to pick number 0 for our test points. So I'm going to put in the number 0 into the factorization parts that I have here. Therefore, I'm going to have 0 minus 6, 0 plus 2 less than or equal to 0. So here I'm going to have -6 times 2 less than or equal to 0. So -12 is less than or equal to 0. Therefore, this is the correct one. Now, let us try to do the test point for either of this region to see the result. So let's say I do a test point for this region. So x is greater than or equal to 6. So I'm going to use number 7 for this region as the test point. So 7 minus 6, 7 plus 2 less than or equal to 0. So here this one is going to be 1. This is going to be 9. So if I multiply it, I'm going to have 9. So 9 is greater than 0. Therefore, this part here is not correct. Therefore, this region is not the solutions for question C. And if you do it for x less than or equal to -2, you will find it is not correct as well. Therefore, the solution will be x greater than or equal to -2, less than or equal to 6. Question D. So first, I'm going to expand for this part and move everything to the left. So I'm going to have x squared minus 2x, and this 3 will be -3 greater than or equal to 0. Then factorize for this part, you're going to have x minus 3, x plus 1 greater than or equal to 0. So to find the root, we're going to let this quadratic inequalities equal to 0. So when x minus 3, x plus 1 equal to 0, so x is equal to 3 or x is equal to -1. So on the number lines here, -1 will be on the left and the +3 will be on the right. For this quadratic inequalities, it is greater than or equal to 0. Therefore, the solutions will be on the positive part, which will be on the regions x greater than or equal to 3, and the other positive region will be x less than or equal to -1. If you want to confirm the answer, you can do a test point for these positive regions. For example, for these regions, as x is greater than or equal to 3, let us choose number 4 as our test point. So put the number 4 into the linear quadratic inequalities, then you're going to have 4 minus 3, 4 plus 1 greater than or equal to 0. So here is going to be 1 times 5. So it will be 5 greater than or equal to 0. Therefore, this one is a correct one. And for these regions, as this is x is less than or equal to -1, so let us choose, for example, -2 as our test point. So you're going to have -2 minus 3, -2 plus 1 greater than or equal to 0. So here you're going to have -5, here you're going to have -1 greater than or equal to 0. So -5 times -1, which is +5, is greater than or equal to 0. Therefore, this is correct as well. So therefore, the solutions for questions D is x less than or equal to -1 or x greater than or equal to 3. For question E and F, we're going to solve this using the table method. So look at question E first. So this is a square, so it means x plus 2 multiply x plus 2 less than 2x plus 7. So for this part, we want to do the expansion. So we want to get x squared plus 4x plus 4 less than 2x plus 7. Then we're going to move everything to the left hand side. X squared plus 4x minus 2x plus 4 minus 7 less than 0. So we're going to solve for the like term here. X squared plus 2x minus 3 less than 0. Next, we're going to do the factorizations. So it's going to be x plus 3. Another one is x minus 1 less than 0. Next, to find the roots, so we're going to let this quadratic inequalities equal to 0. So when x plus 3, x minus 1 equal to 0, the x is equal to negative 3 or x is equal to 1. Now, the roots that we have here is going to create the range of the value of x. So for this table, for this part, is the range going to be x less than negative 3. This part is the x greater than negative 3 and less than 1. And for this part, x is greater than 1. And for this column here, we want to fill in with the factorization part that we do here. So this is going to be the x plus 3. This is x minus 1, and this is the combinations of the two brackets, x plus 3, x minus 1. Now, to solve this, so for this range of x, which is x less than negative 3, so we're going to choose a number, which is, for example, negative 4, and we're going to insert it into the x that we have here. So, negative 4 plus 3 will give you the answer of negative 1. So the answer is a negative answer. And when we put negative 4 into this bracket, negative 4 minus 1, which is negative 5, you're going to get a negative number as well. So when these two brackets multiply each other, negative multiply a negative number, then you're going to get a positive answer, which is greater than 0. And for this range, x is in between negative 3 and 1. So I'm going to choose number 0 here to fill in into the x. So 0 plus 3 equal to 3, which is a positive answer. And when 0 minus 1, you're going to get negative 1, which is a negative answer. So when these two brackets multiply each other, a positive multiply a negative number, then you're going to get a negative answer, which is less than 0. Now for this part, the range is greater than 1, so I'm going to choose number 2 here and fill it into the bracket. 2 plus 3 equal to 5, a positive answer. 2 minus 1 equal to 1, which is a positive answer. So when these two multiply each other, then you're going to get a positive answer, which is greater than 0. And for this quadratic inequalities, it is less than 0, which means the range of value of x is on the negative part here. So the range of value of x for questions E, the x is greater than negative 3 and less than 1. Question F. So for this part, I'm going to do the expansions. So you're going to get 15x minus 3x squared plus 5 minus x greater than 13. We're going to rearrange this and move this 13 to the left hand side. Negative 3x squared plus 15x minus x plus 5 minus 13 greater than 0. Solve for the like term. So here you're going to get 14x, this part minus x greater than 0. To do for the factorization part here, I'm going to let the coefficients for the x squared to be positive. Therefore, I'm going to divide every term here with negative 1. So here I'm going to have 3x squared minus 14x plus 8. So when you divide an inequalities with a negative number, so the sign here will be reversed. Now it's going to be less than 0. For the factorization part, you're going to get 3x minus 2, x minus 4, less than 0. Now, to find the root, we're going to let this quadratic inequalities equal to 0. So when 3x minus 2, x minus 4 equal to 0, x is equal to 2 over 3, or x is equal to 4. So the roots here is going to create the range of the value of x here. So here is going to be x less than 2 over 3. Here the x is greater than 2 over 3, less than 4. And this part, x is greater than 4. And so for this part, we're going to fill in with the factorization part that we have here. So the first bracket is 3x minus 2. The second bracket, x minus 4. This part is the combination of the two brackets. So here, the x is less than 2 over 3. So I'm going to choose number 0, as 0 is less than 2 over 3. And I'm going to fill in into the bracket that I have here. So you're going to have 3, 0 minus 2, which is equal to negative 2, a negative answer. For this one, 0 minus 4, negative 4, a negative answer as well. So when these two brackets multiply each other, negative multiply negative, you're going to get a positive answer, which is greater than 0. So for this part, the x is greater than 2 over 3 and less than 4. So I'm going to choose number 1. I'm going to fill it into the brackets. So 3 times 1 minus 2, which is equal to 1, positive answer. And for this one, 1 minus 4 equal to negative 3, a negative answer. So when these two brackets multiply each other, you're going to get a negative answer, which is less than 0. X greater than 4, I'm going to choose number 5 here. So 3 times 5 is 15, minus 2 is 13, so a positive number. 5 minus 4, which is 1, a positive number. So when these two brackets multiply each other, positive, positive, you want to get a positive answer, which is greater than 0. Now, go back to this quadratic inequalities, it is less than 0. So, therefore, the answer will be a negative number. So, the range of value of x for questions F, the x is greater than 2 over 3 and less than 4. Question number 2. Find the range of value of x for these linear inequalities. So first, we're going to expand these parts. So here you're going to have 2x squared plus x. Then we're going to move everything to the left hand side. Minus 2x squared minus 5x minus x minus 16 greater than or equal to 0. Then we're going to solve for the like term. X squared minus 6x minus 16 greater than or equal to 0. Then we're going to do the factorizations for this part. You're going to add x minus 8, and another one is x plus 2 greater than or equal to 0. To find the roots, we're going to let these quadratic equations equal to 0 when x minus 8, x plus 2 equal to 0, the x is equal to 8, or the x is equal to negative 2. Now, to find the range of value of x, you can solve it either using the graph sketching method, number lines method, or table method. So, for these questions, I'm going to show it using the graph sketching method. Now, this is the graph that you're going to get after you plot it based on the quadratic inequalities that we have here. So the a here for the x squared is a positive 1, so that's why you're going to have a U shape. And the y-intercept, which is the negative 16, so it will be here. And the root, this one is a negative 2, here is going to be the 8. And for this quadratic inequalities, it is greater than or equal to 0. Thus, the range of value of x is determined on the graph above the x-axis. So it will be here. Another one will be on this side. So for this range here, the x is greater than or equal to 8. And for this one, the x is less than or equal to -2. So these two here, x less than or equal to -2 or x greater than or equal to 8 are the range of value of x for questions number 2.